In Chapter 9, we'll study some basic ideas of probability, and we'll discuss certain terms that are commonly used in explaining probability. Let's start with the first problem of tossing a coin. When a coin is tossed, there are two possibilities. You can either get heads or tails. So these are the only two possibilities. Now, if I say what is the probability of heads, you would say 1/2 or 50%, because there are exactly two possibilities. Both are equally likely. So if both are equally likely, then the probability of getting one of them would be 1 out of 2, which is equal to 0.5 or 50%. So we figured out the probabilities without actually doing any experiment. So that is called theoretical probability. Now we'll try to figure out the probability of getting heads or the probability of getting tails when tossing a coin by actually doing an experiment. We'll toss a coin 10 times and record the number of heads and number of tails. So I did this experiment, and let's say I got these numbers, 6 heads and 4 tails. So based on this experiment, my probability of getting heads is 6 out of 10, which is 3/5, and the probability of getting tails is 4 out of 10, which is 2/5. Now this doesn't agree with what we said the probability of each outcome, that is getting heads and getting tails, is. The reason why the two numbers don't agree is because the number of times we toss the coin is just 10. Now, what if we toss the coin 20 times or 30 times or 40 or 100 or 1,000 times? Now, as we keep increasing the number of times we toss the coin, the probabilities we calculate from our experiment get closer and closer to what we expect from theory, that is probability of heads equals half and probability of tails also equals half. Now in probability, we're interested in random phenomena, phenomena for which the outcomes are not certain. So for example, if we want to watch if it'll rain tomorrow, one of the two things could happen. It's possible that it will rain tomorrow, or maybe it will not rain tomorrow. But it could be one of these two possible outcomes, but we're only going to find out tomorrow what's going to happen. So that's our first example of a random phenomena. The second one is when you send out a survey and you ask the individual to fill out the gender. You don't know who's filling out the form, so it could be one of the two possibilities, male or female. So that would be, again, a random phenomena, noting down the gender of the individual who sends out the survey. Now, if you're watching the stock price of Walmart tomorrow, then one of the three things could happen. The stock price can maybe increase from today, decrease from today's price, or remain the same. But the outcome is not certain. We'll only find out tomorrow what's going to happen. Now this problem will give you a basic idea of probability. Probability is a measure of the chance of some event to occur. So it's a number between 0 and 1. And if you've done any probability, you've probably come across that before. It's a number between 0 and 1. We also use percentages, so it could be a number between 0 and 100%. So 100% is 100 over 100, which is really equal to a 1. So either way, your number is between 0 and 1. So if an event is impossible, what is the measure of probability of occurrence of that event? An impossible event, it is never ever going to happen. The probability of that happening is equal to 0. If an event is certainly going to happen, then the probability is a maximum, which is 1. If it's certainly going to happen, then there's a 100% chance of happening, and 100% is equal to 1. This event is unlikely, but it'll occur once in a while in a long sequence of trials. So 0.01 seems to fit that description, because if you change 0.01 to a fraction, it is 1 over 100, which means that on an average the event will occur once in every 100 trials. Now part D is the event will occur more often than not. So 6 tenths, or 0.6 is the same as 6 tenths. So it's going to happen on an average 6 out of 10 times. And then the probability of that not happening would be 4 out of 10 times. So more often than not would be a good description of this event. Using the example of rolling a die, we'll discuss 3 terms. One is sample space, the second is event, and the third is a probability model. So let's roll a die. There are 6 possible outcomes, and the 6 possible outcomes are 1, 2, 3, 4, 5, and 6. So that complete list of all possible outcomes, starting with 1, going up to 6, is called the sample space of that experiment. Sample space is nothing but a set of all possible outcomes of an experiment. So if the outcomes can be listed, then make sure you're separating the outcomes with commas, and making sure that you're putting all the outcomes together as a set, which means we use these fancy brackets or braces. So that would be the sample space. Now, for example, if I say I'm rolling a die, what is the probability of the event of getting let's say an even number? So getting an even number when we roll a die, any one of the 3 things could happen. That is, you could get a 2, 4, or a 6. Notice that this is just a piece of the sample space, and that would be an event. Event is just a part of the sample space, or it's a subset of the sample space. So you can either describe an event in words or list the outcomes sometimes. Now the next term is a probability model. This is exactly what a probability model is, and it has to satisfy certain conditions. First, we list all possible outcomes. Second, we list the probabilities of those outcomes. So the probability of getting a 1 is 1/6, 2 is a 1/6, and so on. We make sure that our calculations of probability are correct, which means the numbers lie between 0 and 1. And then when we add up all the numbers, we have 6/6, we add up all the numbers, we get a 1. So these 4 conditions together tell us that the given table is a legitimate, a correct probability model. Now in this question, we'll see different examples of sample spaces. So the first one is ask whether a student is male or female. Now we list all possible outcomes and write it correctly with commas separating the outcomes and the brackets, and that would make the sample space of the experiment. So there are only 2 possibilities. A person can be male or female, and that would give us the complete sample space of this experiment. Notice that we were able to list the possible outcomes, and we separated outcomes with commas. So when it's a list, we separate outcomes with commas. Also note that it is not called a variable unless it is a measurement. It's just a set that can be listed. The next question is ask students' blood type. So we can list blood types in 2 different ways, one with the RH factor and the other without the RH factor. and both are listable in the sense we can write down the separate individual outcomes. We separate them with commas. Remember to put your commas between outcomes and make it a set or a collection of objects. So you use the braces to enclose all the outcomes in the form of a set. So this is called an experiment with discrete outcomes. Now the next one is how many times in a day a student brushes his or her teeth. So the possibilities are 0 through, and then you can keep going on and on. Never put a limit, because what if you stop at 25? There may be somebody who says, oh, I brush 26 times. So just leave it open. It's okay to have numbers that probably will never be outcomes, but then you want to make sure that you don't leave anything out. So that would be our sample space. So the dot 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 just means that it just goes, the list goes on and on. However, even though it just goes on and on forever, it's still listable. We know that there's a pattern and the pattern continues. So you start with a 0, you go to 1, 2, 3. So it's, if you're looking at a number line, it starts with 0, and then it goes to 1, then 2, then 3, then 4, and then it keeps going on and on, leaving everything in between, just going to the whole numbers. So it's listable, so it's a discrete variable. Now we can call this a variable because it's a numerical value. Now the next question is, how long has it been since the student's last flu or cold? Now here is a problem or a question for which the answers cannot be listed. Think of all possible answers. What we're doing here is measuring the length of time. Now time could be given in hours, in days, in months, in years, and then finally we convert it all to days, any one particular unit of measurement. And then it's possible that the answers are like 3.5 days or 369.8 days. Now any one of these could be possible answers. So we cannot list all possible outcomes. We didn't say give me the number of days. The minute I say give me the number of days, then it becomes a count, and in that case the answer can be 0, 1, 2, 3, and so on. But that's not what has been asked. It said give the length of time. It's a measurement of time, and that cannot be done in whole numbers. Now if a measurement is not in whole numbers, then it cannot be listed. And if it cannot be listed, and it's a numerical value that cannot be listed, then it is called a continuous variable. So the word continuous goes with numbers that cannot be listed. So if the numbers cannot be listed, then how exactly do we write down the sample space? Now if you remember from algebra, this is your number line. We are looking at all numbers including 0 and to the right of it. What we do is use what's called the interval notation. This means include 0. That's a square bracket which says include 0. That's your lower limit, and then keep going on and on forever to the right. So that's the term infinity is used to describe going on, and then it's positive infinity, which means you're going in the positive direction of the x-axis. So an interval is nothing but a range of values. So if I say the interval is from 5 to, let's say, 8, it's all numbers including 5. So you're going to include 5, and every single number to the right of 5. We stop at 8. We are not going to include 8. That's what this means, not included. 8 is not included, but anything up to 8 is included. So every little every number between 5 and 8 is accounted for. So it's nothing but a range of values, but you got to write it carefully. If that's a 0 and you want all the numbers to the left of 0, then you describe it as negative infinity to 0. And if I use these brackets, it means that 0 is not included.